here we are now making video for the second part of the assignment, which is part B. So let us see what we have to do in this part. So basically here we have to make a video of 5 to 8 minutes. Here we have given a CF file of BATIO3. So we have given the crystal structure of the BATIO3 and different information about it. So with the help of that BATIO3 file, CF file, we need to make few changes, like the cell parameter that we have to change. It is a cubic structure, so for all the cell parameter A will be equal to B equal to C. So for all of them it will be same. So like for A equal to B equal to C. Like here the first compound calcium telluride CATE follows a rock salt structure with a cell parameter 6.356 Armstrong. Similarly for GAP, K2O, CO2 and AUZN. We have to make the CF file for it, and we have to open the CF file using the software VISTA, where we can just represent the structures. So let's begin here. Let me first open the CIF file of the BATIO3. So here let me open the text editor. Sorry. So here's the text editor. So here's the file of the beryllium BATIO3. So it's not a cubic structure, basically it's a primitive with no symmetry here. P1 signifies it. Its space group is given by 1, and the angles between all, since angle is given by 90 degree. Its volume is 65, like multiplication of all A, B, C, and the cell lengths are given as 3.99 and 3.99 4.102 Armstrongs. So and the different things are provided here. Basically we don't care much about all these stuff, so we are basically checking the fractional coordinates. We will just change over the fractional coordinates so that it will alter the positions of the atom, so we can able to see the structure. So let's start with the BATIO3. So here BA0, like one of the barium atom is with the 100% occupancy, is situated at the 0.5, 0.5, 0.5 fractional coordinate. That is x is situated 0.5, y is 0.5 and z is 0. That is at the center barium occupied. Then surrounded by titanium, then oxygen atoms are there. So we can go over and check its CF file. So let's open. Here we open all different files. So we start with the BATIO3 file. So here you can see the BATIO3 file. You can here just show, you can check over like barium atom is represented by green, so you can see that it has occupied the center position here. Okay, and then titanium atoms are here. So like if I just click it where B, like, or A, titanium atom is shown by B shown by the blue color. So you can see that all the corner atoms were occupied by the titanium atom. And then when we check over the walls, and then you can see that oxygen atoms are represented by the radiant colors. So in this way we have represented here. You can also see here the structural parameters are given for all compounds here, for oxygen and other compounds here. So in this similarly process we can check for the other compound. So let's begin. So the first compound that we need to check is for the calcium telluride CATE with a cell parameter of 6.356, which follows the rock salt structure. So let me just open the text editor here. So text editor here. So I can go for the CATE file. You can see it here. We have keep everything similar, like we can change these things, like cell volume need to be changed, we need to change the space group and the space group number, but we didn't get much. Like if we are changing the fractional coordinates here, so basically we are changing the cell parameters and the fractional coordinates here, so basically that can all take into the effect, that will count everything. So therefore no specific need to change all this stuff. So here CATE follows the rock salt structure. It's like calcium occupies the octahedral voids, therefore calcium which occupies the octahedral voids, and the beryllium Te occupied the face center, like the corner atoms and the center of faces is occupied by the calcium telluride. So we can just go and check for its VISTA file. So let me open the VISTA file of it. So here is a CATE. So as you can see, the calcium is represented by blue here. So calcium has occupied has occupied the voids here. You can see as that, okay, as the voids has been occupied calcium, and then the tellurium has occupied the corner atoms and the center of the faces, as you can see, like the center of the faces and are occupied by the tellurium atom. So it is the structure of calcium telluride CaTe. So we can now move ahead with other files. So the next file is of the GAP. GAP with a cell parameter of the 5.448 angstrom following the zinc plate structure. So let me just open the text file here. I can open the text file here. Just wait. Okay. So we want to see this. We want to zinc plate structure of GAP. So we can go to GAP here. 5.448 was given to us, and we have changed the fractional coordinates of it accordingly. How we have changed the fractional coordinates, let me show you via the VISTA. So you can just go on the VISTA software, GAP we can open it. Here you can observe it. So the pink atoms are of the P element, phosphorus element, and the G is the gallium element here. So you can see that gallium zinc is a zinc blende structure. So gallium occupied the tetrahedral voids. So basically the gallium atom is here, is occupying tetrahedral voids. You can see here. So it's one tetrahedral void is occupied by the gallium here, tetrahedral voids are occupied by the gallium here, and the P is phosphorus forming the FCC. So like the we can just like say, so the corner atom and the face center atom is occupied by the gallium. Sorry, it is occupied by the phosphorus. So that's the structure of the gallium phosphate. Let's go ahead with the third one, K2O with cell parameter of 6.449 angstrom. So here let me just open the CIF file of it. It's K. So I was K2O is here, 6.449 angstrom here, and here we have changes all the like the zeroth oxygen here, all the potassium atom and the oxygen atom position. So like how we defined it, let me just show to it the VISTA file. If I just move to the VISTA file of the K2O, you will see here it's antifluoride structure. So basically in the antifluoride structure, potassium ion here will occupy the FCC and the oxygen atoms will occupy the all the tetrahedral voids. So as you can see that oxygen atoms are represented by reds. So all the tetrahedral voids are occupied. You can see the tetrahedral voids have been occupied by the oxygen atom, and the potassium here has formed FCC. Potassium is forming the SCC here. So it is as simple as that. So we can move forward ahead with this other element like CEO2 with the cell parameter of 5.4110. You can just go and check for the CEO2. It's like a fluoride structure. So in the fluoride structure there is a quite change. Here metals form the FCC and the non-metals occupy the tetrahedral voids. So basically you can see the structure here. Here the fractional coordinates were given now. Let me open the VISTA file of it. So opening the VISTA file CEO2, here we can see how things are there. Let me just make it okay. So here the green elements are represented by the selenium and oxygen represented by the red. So here you can see that CEG is forming the FCC and the oxygen is now occupying all the tetrahedral voids, while in other cases it was like the anion was occupying the FCC and the cations were occupying the voids there. So it's a quite different here. It's a fluoride structure. So that's the structure of the CEO2, which is a fluoride structure. Hope it is easy to understand. Let me show it via different axes. Then coming to the last part of the last structure that we are given is of AUZN. So it's basically a CSCl structure. It is basically primitive structure. So like the corner atoms, gold occupy the corner atoms, and zinc is lies on the center of the cubic void. So you just can go through it. Let me minimize it. Let me open the text file of it. So you can just go over through it. It's easy. And oxygen is one there, and the zinc occupying the center. So center is occupying by the zinc and the gold occupies the corner atoms here. So we can check over the VISTA files for it. Sorry. So here the VISTA file of the compound, you can see that gold here occupies the corner atoms and the center one is occupied by the zinc one. So this is the structure of the UZN. So basically all these are the VISTA files of the following thing, and we have represented every structure with this help of, we have taken the reference of the BATIO3 for our understanding, and you can do lot of stuff from this compound, like we can change the color of this thing, like if I do this, then let me just change the color and then return. So this is also possible. So like we have changed the color of it now, so we can change the color of the things. We can also have different options here, like ball and stick is one of the representation. We can go for the space filling, polyhedral, wireframe is though nice representation, stick is one representation, but ball and stick being convenient, like it help us to observe molecules and the bonds, so it's one of the easiest way to understand. So that's all from my side. I hope everything is clear. So now let me conclude. So this was the second part of the assignment, where we have discussed about the compounds, their cell parameters, and how their structures are there, and we have discussed how their structures look like through the help of the VESTA software. Thanks for your time.